So ladies and gentlemen, I'm very happy to be here and thanks a lot for the organizers inviting me from Germany to fly here. I think my talk is perhaps a very challenging duty, a very challenging topic. I have to explain you how to set up ingot and wafer factories abroad in foreign countries. And so I will talk about our own experience in doing like this. First, quickly about RCT. We have RCT Solutions in the RCT group. This company is an engineering company based in Germany, India, Turkey, where we are setting up gigascale factories for our customer. Currently, we have about 73 gigawatt of factory capacity in our books, mostly ingot, wafer, and cell factories. Then we have RCT Power. There we are a manufacturer. We have 2 factories in Suzhou. We are building big containerized batteries, C&I products, and inverters in Germany. So far, we have shipped about 14.5 gigawatt hours of storage products globally, mainly in USA, in Australia, and in Europe. Then we have, as a next step, RCT Hydrogen. There we are turnkey provider and equipment provider to produce green hydrogen or industrial scale hydrogen. And then we are giving money, financing with RCT Finance Advisory. We are currently headquartered in Germany. We have 650 people are working for RCT Group, and we are active in 27 countries, including USA, China, India, Malaysia. Good. Now, first, let us look into ingot and wafer production. So, now, you might ask, as my Chinese friends, why we need ingot and wafer production outside China. There's a lot of capacity in China, perhaps too much capacity in China. Why these other guys in India, in Germany, in Europe and USA want to make ingot and wafer? That's a very important question. And what is the answer? We have understood that the Western world cannot only rely on China, because it's a transition, it's a global big industrial transition, and it should be on the shoulder of more people than only the Chinese people, hardworking Chinese people. Although the Western people have to work hard and make ingot, wafer, cell, and module. So if you look also at government regulations, we see countries who are even quite a little bit negative on China, like USA. They're putting tariffs and they're subsidizing local manufacturing. Countries like India who want to be independent. And of course we have to understand that those people who are using wide-scale solar, they want to have local jobs. They want to have local engagements, local technologies, local machines. And this is a matter of fact which we have to accept. And I invite all the Chinese big players and machine makers, come to the Western world. Come to the Western world. And I will explain by ingot and wafer factory setting up, what are the challenges associated. If you look at setting up a whole ecosystem outside China, of course we have all these layers of the value chain. And it's not all about setting up production capacities, because you operate those production capacities. You need to train people. You have to install equipment. You have to do service. You have to further develop those products. So it's not all about hammering machines into the ground and let them run. That's not possible. So if you do this, if you do yourself or you're supporting people outside China, be prepared to stay locally, to stay in India, to stay in Europe, to stay there and train the people. Now you see, this is the dark blue, that's you, that's China. And there you see ingot and wafer. There the Western world is nearly nothing. There is empty. We are not prepared to make ingot and wafer. Of course, the Western world has an experience in semiconductor industry. We can make ingots, we can make wafers, that's for sure. But mostly, so far, we have been focusing on high-quality semiconductor wafers. We have big players like Wafer and others who are doing this. But the low-cost solar wafers, we forgot a little bit how to do. And that's something which has to come back in the Western world. And I will explain you how it could be done. Now, we are going into how to execute an ingot and wafer project overseas. That's a different world. Here you see the production chain of ingot and wafer production, and I think most of you know how to produce an ingot and how to produce a wafer. That are the different stages. And of course we have critical parts. First of all, to grow an ingot of 5.6 meter length if we are used to semiconductor wafers which are much shorter. And of course we have the time forever to make such semiconductor wafers. And then wafer cutting, very thin wafers. These all are the challenges which we are facing in the Western world. Here you see another challenge what we are facing is a wafer format. Because the industry is moving a lot in fuzzling around. So if an Indian customer is coming to us, they're asking, Peter, which wafer size we should do? G12, G12R, G12 something, M10 something. And that's of course a challenge because the cell equipment has to match to the wafer factory. And I would say currently we see from abroad, mostly the customer asking G12 wafer and G12R wafer capacities. But on the other side, you have to machinery compatible. Perhaps somebody is jumping to another wafer format. The foreign factories have to be compatible to handle all formats, which are possible. And of course, then our customer asking about crucible loading. How to get the crucibles? From whom? In the Western world, we don't have crucible factories. So all these are the challenges, especially when you go to big size ingot and wafer production. That's a challenge. The supply chain, diamond wire, that's a big challenge. Now how we start the project. So currently we are doing, Jun, how many? Five factory, ingot and wafer factories we are doing roughly in India. All of them are located in India. One factory we accomplished in Turkey, in Kalyon PV. So first, what is the key important is you have to make a feasibility study, detailed project report. And then you have to prepare the project, and I will explain you later on the different phases to execute an ingot and wafer project. Then the initial stage also includes the conceptual engineering and the site location selection, because of course we have to select the right site with a good cost locations, having sufficient workers, cheap energy and very reliable energy provision. And that means all this preparation work in the first phase has to be done very carefully. After doing the conceptual engineering, normally we are doing the basic engineering to know more or less how the factory will look like, including layout studies, equipment selection, and technology selection. Then after the basic engineering is nearly done, you can start the construction work. Then you're doing construction work, and you are onboarding the equipment vendor by international biddings. So always we are inviting Chinese equipment makers and Western equipment makers to join those biddings. And then we are doing detailed engineering. Then after that, procurement and construction supervision. And then after all this ingot and wafers equipment is assembled, then we are doing ramp up training of 1,000 workers, 500 workers, depending on the factory size. Good, and then not enough if the factory is handed over to the customer, not enough. Because normally always a customer needs operations and maintenance support. Because when the line is installed, the KPI are reached, you have to keep the people running, the machines running. And that means normally you have to stay 1-2 more years on site for operations and maintenance support. Good. Now let us look in one project, which we have done in India. It's a 2 gigawatt ingot and wafer factory. So, what are our activities in ingot and wafer? In India, we have currently capacities to be commissioned 10 gigawatt, and 30 gigawatts are coming to us. So in India, we are currently setting up finally 30 gigawatt of ingot and wafer capacity via RCT, and our partners, you can see the who is who of the Indian sector is there. Reliance, Tata, Avada. All those guys want to go into ingot and wafer production now. And that's mostly because the Indian government is supporting this local content, local requirement. And when there's enough ingot and wafer capacity in India, they will put customs to outside ingot and wafer, or let us say wafer, like they do with cell, like they did with module. So India will go into ingot and wafer production for sure. Now, let us look at the mentioned 2 gigawatt ingot and wafer project, which RCT did So it was an ingot factory. We had to do puller installation. We were using Chinese equipment. And the ramp-up engineers were German and Turkish ramp-up engineers supported by Indian engineers. And now the factory is in full operation. For that ramp-up work, we need about 30 people from RCT. And of course, hundreds of people from the customer. Here it's how it looks like, a known picture of which you know. Here is a project in construction phase, in the pre-engineered industrial building. Here you see the start of installation and commissioning, puller by puller, and I will explain you later on how this installation commissioning was done. And then on-site assembly and commissioning and training of the team. So here you see our 30 people who did this installation and commissioning. Now let us look. So what you also need is, as I mentioned to you, training. Before I show you, you put in the building, you put in the machines, but training the customer engineers, that's the key. You need a lot of documents and training courses. We did more than 2,000 training hours to the Indian team to let them be able to do those operations. And a lot of documents you have to share with the customer. And then what is also very important, a document which I like too much, project definition document. Because all of us knows that there is a customer, he says, oh, Peter, I need 2 giga. No, I need 2.5 giga. No. Now we go to G12. No, G12R. So always the project is moving. So you have to make a very accurate, at the beginning with the owner, signed by the owner, a very accurate project definition document. If not, the factory project is moving and always moving, you will never finish. So project definition document, I can all recommend you, Chinese equipment maker, make it very clear what the customer want to have at the day 0, not at the day 200. Then, what you have to do. So our duty was within 24 weeks, we had to ramp up this ingot and wafer factory in India. So first of all, you have the KPIs, which are charge size, yield, cycle time, how many ingots per batch have to be done, resistivity range, and of course wafer quality. Then for the wafer thickness, wafer size, and then of course now we are going to the sub-duties, process and equipment stability have to be shown, operator skill gaps and SOP compliance, environmental and safety, which is a big concern in ingot and wafer factory. And then, of course, you have to show that the factory can run at predefined cost, which means material consumption has to be very clearly defined and reached. So it's not only about KPIs, it's about also cost. You have to guarantee the cost of this factory, which means consumption. And what we have observed as challenges, of course, when we wrapped up this factory, wafer breakage and defects were observed. That's normal, so you have to optimize it step by step. Then ingot structure loss we observed. But what is more important, according to our observation, is the environmental and safety hazards. And that we observed in all our ingot and wafer projects. You can train the customer engineers as much as you can. Always there is something in the ramp-up. Chaotic, hectic, people are not concentrated and something is happening. So for example, we had fire in the production line because you know silicon powder mixed with water can burn. So we have observed 2 times fire. So you need a good fire extinguisher. And also we have observed hydrogen explosion because you're accumulating silicon dust in the wastewater treatment facility that makes hydrogen, and if somebody is not careful, it explodes. So be very careful when you do this type of ingot and wafer factory. You have to be very careful. Then, of course, operator skills. We have observed in our Turkish factory a lot of fluctuation because the foreign workforce is not meant to work 12 hours and 7 days per week. And then they don't like this work, they're changing, and if you have a skilled operator in your factory and he's changing all the time, then it's of course a challenge. And then you have to train them again. And then what we also, of course, at the ramp up, we saw a too high consumption of most of the consumables at the beginning. And after you can see a Pareto analysis about the impact of different parameters on the process stability. And you can see here the highest contribution is of course a process stability, and then of course operator gap analysis we have done. Now here you see the ramp ups result on different KPIs like material yield, like wire breakage rate and wafer chipping rate. And you see over the 24 weeks at the beginning, you can ramp up. In China, you hammer the factory into the ground, you switch on the machines, and after 4 weeks, it's working. In Western world, it's unfortunately not like this. So because the wafer factories, when you ramp it up at full steam, but the KPIs are not reached, you prepare a lot of trash. The working capital is running out. So what you have to do first, you have to reach a certain minimum yield, minimum KPI level, and then you can scale up the factory. So it's a different operating mode as you're doing it in China. You have to do it always driven by cash flow and working capital, not like by lead time to market. Here you see the current status of this factory, some nice photos. Also, as I mentioned to you, operators is a key because you have to train hundreds of workers. And this training schedule has to be very precisely done. And especially, as I mentioned to you, safety and environmental concerns is a key. You can easily have serious accidents. For example, cooling water is not coming, pullers are exploding, and that's the key. So I highly recommend to focus, if you ramp up an ingot and wafer factory, to focus very seriously on safety matters. And that has to be a very strict point of your ramping up. Yeah, I can jump a little bit because of sake of time. Yeah, so what we have done is when we installed the pullers and did puller and ingot puller commissioning, after some first training in the first weeks, we could reduce the lead time to install the pullers from a beginning 300 hours to 165 hours. And that training and installation commissioning comes step by step. So that helps you at the beginning, you're super slow, your boss is kicking you while you're not faster, but step by step you can improve the installation commissioning performance. Here you see also the hours per puller, as I mentioned to you, throughout these 24 weeks, at the beginning we need 300 hours, at the end 165 hours of installation time for the pullers. And here you see the details, how we could further reduce this installation and commissioning step by step. Good, now I'm coming to the end. Good, so what is my conclusion? First of all, you can set up ingot and wafer factories abroad, and we have done it. We have done Kalyon, which was 750 megawatt, and we have done another Indian customer, which is 2 gigawatt. Now we are busy with one customer who is doing at one shot 30 gigawatt, another customer 4 gigawatt, another customer 3 gigawatt. So the world is going into this ingot and wafer production. So it means you can find sites, you can find talented people and ramping up. But as I tell you, it's not working like in China. It's a total different experience. Myself, I was dealing with 750 megawatt in Turkey, and I got less hair and gray hair. So please, if you want to be partnering, if you want to partner with the Western world, you have to adjust to the Western conditions. We don't have that industry background as a Chinese sector has. But I would highly invite you to join such journey in the Western world and to support such initiatives with your talent as machine maker, as manufacturer, because the Western world will need to have their own jobs, will need to have their own capacity, either with or without China. Without China, it will take longer, but it will come. With China, it will go faster, and the Chinese sector has some benefit for it. So thanks a lot for your patience to listen to me.